Hello, good evening, guys. Happy Monday. We meet again. This is our June week 4. Hey, there's only two of you today, huh? Hi, Carol, how are you? Hello, Zihan. There's only two of you today. Why? Because it's holiday this week, is it? Okay, guys. We were here, huh? Oh, why? Speaking of dollars, import GIF as bro. Oh, they don't. Okay, they allow me to put GIF as background, so hence my background. Hello, Sinteng, how are you? Hang on, guys. I'm getting a bit bored of this. Let me change this a little. What am I changing to? Okay, let me change to this. Okay. Hope this is better. I don't know. Go Google lah. I'm sure they teach you how. So guys, this is our June week 4, huh? We were halfway through here, huh? We were halfway through here. Guys, do you want me to continue the exercise or do you want me to finish this chapter first? Do you want the exercise first or do you want to listen first? Guys, which one do you want? You don't mind? You don't mind? That means I finish this first lah, huh? Are you guys okay? I finish this part first. Because we were halfway through here. We finished what is metal and non-metal already. As you learned last week, what are the famous metals and how are metals like? And we learn what is non-metal, what are the non-metals, and also how are they like. Okay, and this is the reaction thing. Okay, guys, let's talk about reaction. Okay, very easy. Reaction is like a relationship. Okay, reaction is like a romantic relationship. Guys, you can only okay, I know I might get in some of you might disagree. Usually a romantic relationship is between a boy and a girl. Okay, before you tell me all the LGBT thing doesn't apply here. So you see, reaction is between metal and non-metal. This is the boy and this is the girl. All right, so when metal and non-metal they get together, that is a relationship. Okay, so you see, chemistry is about this. Chemistry is about which boy will marry which girl and what happens when they divorce. So that's all these things, right? So metals and non-metals undergo chemical reactions to form a compound. I'm sure you remember what a compound is, element compound. Okay, we learned this last chapter. For example, sodium, I see sodium is an element. Sodium is an element. Chlorine is another element. So when they come together, you get sodium chloride. So sodium chloride is a compound. I think you know what is this lah. This is your salt. The salt that you eat, the salt you put in your soup, the salt you put in your food. That is the sodium chloride, right? Like zinc plus sulfur, you get zinc sulfide. Copper plus oxygen, you get copper oxide. Okay, what I want you to take note is, can you see the behind they changed their name? Chlorine becomes chloride, sulfur becomes sulfide, oxygen becomes oxide. It's usually the girl who changes the name. You'll learn more about this next year actually. I mean, if you go to year 9 lah, right? But this is me telling you, usually it's the girl who changes the name. I think you learned this already lor. Last chapter. It's like if I am Mr. Low, okay, which I am, if I'm Mr. Low, if my girlfriend is Miss Lee, if my girlfriend is Miss Lee, when she marries me, she becomes Mrs. Low. She changed her name to become Mrs. Low. So it's the girl who changes the name. Right? Yes. The front marry back. If you get what I mean. Front marry back. Okay, so many metals react with oxygen to form metal oxide. Right? You see? Metal, oxygen, metal oxide. You will learn this next year actually. Right? Most metal oxides are basic or alkaline. If you remember what is alkaline, the opposite of acid. You actually learn acid last year, year 7. Okay, some non-metals also react with oxygen. For example, sulfur reacts with acid to form sulfur dioxide. Hey, sir, this is a girl, right? This is another girl, right? How come they get married one? Rare cases, okay? Rare cases, like you have a girl marrying another girl, which is called a lesbian. Okay, so sometimes, okay, not all the time, only sometimes it happens. Okay, most of the time it's just a guy and a girl. Okay, so most non-metals are oxides are acidic. Okay, this one you don't need to know. Guys, this is just the intro. You will learn more of this next week, and of course more of this in chemistry in year 10 next time. I'm not gonna go too much into this because you haven't learned the basics yet. All right, because we need to learn the equation and the balancing and all that. So I'm not gonna mention about that first. Okay, so let's continue with our exercise, shall we? Shall we? Is everyone with me? Zihan, are you there? Sinteng, are you there? Can you please give me an okay if you're there? Hello? Hello? Are you guys there? Okay, cool. Hey, by the way, guys, I have a question. You guys are having your holiday this Wednesday? Is it? Do you follow normal school holiday? Because normal school holiday, but this Wednesday is like public holiday, right? So you guys are having another holiday, is it? Because that explains the attendance, right? Because usually if it's nearby holiday, then some people won't come. 26th of June. It's only one day, meh? It's only one day, meh? Only 29th of June. Only one day, huh? Oh, okay. Because normal schools is like 28th, 29th, 30th. So it's like Wednesday, Thursday, Friday, and then you continue with Saturday, Sunday. It's like 5 days of holidays. Good, right? You see, you guys are getting too many holidays. Goodness me. Right, so number 2. Let's look at question number 2. We are page 6. We are page 6. Oh, you guys are having summer break, huh? Oh, okay. Okay. So, Carl, after summer break, you are entering a new year or you just continue with this year? Are you entering a new year? Or continue, huh? So you're still in year 8? You're still in year 8. Okay, okay. Okay. But why does your year 8 learn so much though? What does your year 8 learn so much though? No idea. Sinteng, if you don't mind me asking you, Sinteng, if you are there, Sinteng, what do you, is my syllabus similar as your school? Is what you're learning right now same as what you're learning in your school? Yes, you see, yours follow lah. Yours got follow. What's your school again, by the way? Sorry. What's your school again? Oh, so good lah. Your school will follow. That's a good thing lah. That's a good thing lah. So, Carl, your school is the funny one. Why can't they just follow the bloody textbook? Excuse me. Sydney, what school are you from again? If you don't mind me asking. So let's look at number 2. So you have 2 circuits here, and you have 2 different materials. You have copper here, and you have sulfur here. Guys, which one will conduct electricity? Which one will conduct electricity? Which one the light bulb will light up? You already know that because it's copper, because this is the wire material. Okay, this is the wire material. So you have your copper here, bulb, this is lighting. Guys, lighting 跟 lightning 是不一样的 Lighting is 灯光 lightning is 闪电 different. Okay, this is a typo here. So bulb lighting, does the bulb light up? Okay, so bulb lights up. This one doesn't light up. Okay, you write yourself lah. I'm just gonna put a cross here, you understand? So type of material, copper is a metal. Okay, copper 是金属它叫做铜。And then your sulfur is a non-metal, as in 非金属。 Okay, this one you already know. So B, explain your answer in A. So explain this. Explain this. Why copper will light up leh? Why sulfur won't light up leh? Because copper is a conductor. 铜是导电体. Okay, copper is a conductor. Whereas sulfur is an insulator. 绝缘体. Okay, 绝缘体. Any of you here are from Huaxiao, your Chinese primary school? I believe most of you, or maybe some of you are, right? So if you understand Mandarin lah, because oh, you're from Chinese school. Okay, cool. What about the rest of you, Zihan and Xinting? Are you guys from Chinese school? Are you guys from Chinese school? I don't know what's the thing there. Why is it that you guys are in Chinese? Because Chinese school, Malaysia Chinese school is government, man. Why are you guys okay with Chinese school, but suddenly secondary you're jumping to international? What gives? Why your parents decide to change like that? What's the reason? SMK Malay only not really lah. SMK I would say is a mix lah. Oh, you mean the language ah? Wasn't that good at Chinese. Oh, okay. Oh, Zhihan, you're not very good at Chinese, is it? I see. Okay. Cool. Nice to know more about you guys. But here's the thing lah. I have to say lah, I have to say if you realize this right, if you're from Chinese school last time Hua Xiao's teacher is quite good one. Your primary school's teacher, they are actually quite good. Okay, but if you jump to secondary school, if you happen to go to SMK, if you happen to go to SMK, sorry, you will realize that the school teachers are kind of shit. I'm sorry, but that's the truth. Okay, they're kind of shit. They're lazy as shit, and they don't know what the hell they're doing. Some of them, anyway. So you should be glad that you're in international school. Okay, so C, suggest one other material that can replace copper and sulfur. If I don't want to use copper, what can I use? What can I use? Fe. Ayo, can't just type lah. Fe. No need. Don't write that two. The one is charged already. Okay, one other material I can choose iron. Okay, iron or any metal lah. Any metal. What about sulfur? What can I replace sulfur with? It has to be a solid. So there's not much choice here. What can replace sulfur? Don't write carbon Will you go to write carbon? No, graphite can conduct electricity, you see? Carol? Graphite can conduct electricity So what can you replace it with? Give me a non-metal. Wow, it's really hard, isn't it? Okay, guys, I have an answer here, which is your iodine. Iodine. Cannot lah, gold is here lah. Gold is here. Gold is a metal. Right? Iodine. You know guys, you know what is an iodine? I think I told you this before. Iodine is this thing. It's like a purple color, black color solid. When you heat them, they become purple gas. This is a non-metal, guys. This is a non-metal. This is a cousin of chlorine. So they belong to the same family. Okay, so that's your iodine. So both of the rods are then hit with a hammer. What will happen? If I hit copper, what will happen? Will the copper break? Will copper break when I hammer it? Copper? Does it break or does it bend? Copper bends because copper is ductile. Copper is malleable. Remember? All metals are ductile and malleable. If you remember what is ductile and malleable, means you can beat them into any shape, you can pull them into any shape. Metals are soft, right? Metals are soft. Whereas your sulfur breaks. Okay, it will crack into many pieces, just like your pencil lead. Okay, your pencil lead. All non-metals are very brittle. Okay, brittle, whereas this is ductile and malleable. That's why your house gate, your house, the main gate is made from metal because it's easy to bend. I can make into any shape I want. So E, if copper rod is replaced with carbon rod, predict what will happen when the switch is turned on. If I change this to graphite, Carl, we were just saying this just now. If you change this to carbon, your pencil lead, a pencil lead is a non-metal. Will the bulb light up? Will this bulb light up? Yes or no? Yes or no? Guys, yes or no? Yeah, I'm not gonna mention, I'm not gonna go into that, Carl. That's like metallurgy advanced level already. Okay, so what happens to the light bulb? Will it light up or will it go off? Okay, it will light up, okay, so the bulb continues to light up, right? Because carbon, guys, carbon is the only non-metal that can conduct electricity. I repeat, carbon is the only metal that, sorry, only non-metal that can conduct electricity. Your pencil lead can conduct electricity like any other metal. Your pencil lead can conduct electricity. Guys, you know what is your dry cell? Okay, your dry cell. This is your double A battery. Have you seen your double A battery before? Guys, have you cut it open before? Have you cut it open before? That middle stick that goes to the positive, that is a graphite. So you actually have a pencil lead in your battery. You have a pencil lead in your battery, your dry cell, your double A or triple A, your remote control battery. Actually looks like this, right? So there's a graphite in the middle. Okay, why graphite? Because graphite is cheap and graphite can conduct electricity. So that's why they use graphite. Okay, so next, number 3. The list below shows properties of different metals, different elements. So they are magnetic, very high melting point, blah, 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 blah. Which 2 properties from the list above make aluminium suitable for saucepan? Why do I use aluminium to make pans? What characteristic I want here? Why aluminium? Why not plastic? Right? It's a good conductor of heat. Good. I'm just going to point it here. Good. What else? What else? High melting point. Good. Good. Guys, if you are using it as a induction cooker, if you are using it on an induction cooker, you need a good conductor of electricity. Guys, do you know this? Do you use an induction cooker at home? If you put aluminium on it, it's not gonna function. The thing won't work because it needs something magnetic. All right, that's why I hate. Guys, you know what is an induction cooker? Do you use that at home? That's the stupidest. That's the stupidest stove anyway. The one without fire one. Sometimes when you go hot pot, they will use this thing one. Really hate it because you need iron. You put aluminium, it's not gonna work. So number 2, which property in the list above explains why copper is used in television cable? They only want one property. Why do we use copper as wire? Yes, it's a good conductor of electricity. Good. Copper is not the best, but it's one of the best. And it's cheap. The thing about copper is it's cheap. I mean, you can use gold. Gold is better than copper, but gold is very expensive and it's very heavy. So copper is the most suitable. So B, Why is copper suitable to be made into electrical wire? Wow, I just mentioned it, isn't it? Okay, because it is a good, you can actually copy this answer, good conductor of electricity. C, why is aluminium used to make plane? Because it is ductile, or you can say it is strong, it is ductile, it is malleable. I can easily bend it into any shape. I can easily beat it into any shape, and they are strong. Okay, they can tahan. So D, why is metal not suitable to be used in manufacture of buckets compared to plastic? Why don't we use metals to make bucket? You know bucket? Prevent copper from oxidation. Oh, that's a good question, Carl. Yes, it does. Yes, it does. But mainly is the insulation lah. Mainly is the insulation because copper, they don't oxidize that easily. Even if copper oxidize, right, they still conduct electricity. So a bit of both lah, I would say. A bit of both. Good question. That's a good question. So why metal not for buckets? You know the bucket your mom used to wash clothes. Why don't we use metal? Guys, there's a lot of answer here. Why don't we use metals to make bucket? You know when you mop your floor, you guys mop your floor? When you mop your floor, you will use a bucket, right? Poor conductor. Not really related though. Any else? Anything else? You don't have to just find answer from the top. There can be any answer. You can say it is heavy. Okay, it is heavy. We don't use metal because it's heavy. Imagine if your bucket is made of metal, especially iron, you know how heavy is it? So it's not very practical. All right. And metals, okay, they will corrode or they will rust. If you use iron to make a bucket, your bucket is going to rust. So that's why we don't use iron. We don't use metal. Okay, so E, why is pot made of metal while its handle is made from non-metal such as plastic or wood? Okay, why is the pot made of metal? Because it's to conduct heat to food. And why is the handle made of non-metal material? This is to insulate heat from reaching hand. Okay, so that your... Oh, is it? Okay, good, good for you, good for you. Right? Hey, exam, they come out the same thing. They come out with the same thing? Right, guys. I think this one you learned this last chapter already lah. Copper, they want equation Here equation, copper plus oxygen, you get copper oxide. Remember the girl has to change her name, right? Aluminium plus oxygen, you get aluminium oxide. Easy peasy. Zinc plus oxygen, zinc oxide. Iron, oxygen, iron oxide. What about potassium and water? Okay, potassium plus water, you will get potassium hydroxide plus hydrogen. Oh my God, sir, what is this? Right, I mean the oxygen one is simple enough, but this one you have a hydrogen gas here. Why? Don't ask me why, because it's not in your syllabus. Not yet anyway, right? And guys, I hope it goes without saying, I hope it goes without saying, this is not an equal, this is arrow, If you write equal here, then your answer is wrong. Okay, easy peasy if you don't balance it. There's no need to balance here. There's no need to balance here. Not now anyway. Right, please write arrow, Please write arrow, Many people, they will just ignore one. Okay, so same thing, sodium plus water, you get sodium hydroxide and hydrogen. Calcium plus water, you get calcium hydroxide and hydrogen. Just change the metal to the name you want. This one easy. This three easy. Iron plus sulfur. Yeah, I know, but I'm not mentioning that. Okay, this is FUR. Sorry, there's a typo here. This is the old spelling. you will get iron sulfide. So the next one is copper sulfide. Then you have zinc sulfide. Okay, you write this fully yourself. I'm not gonna bother. I'm not gonna bother. Okay, you guys following so far? I hope you guys following. Okay. Okay, let's finish this if we can. Right, so number 5, Sophia carried out an experiment of burning magnesium tape in the air as shown in the diagram on the next page. Oh, this is on the next page. After the burning, Sophia observed a white powder in the crucible she used. A crucible is this thing. Okay, so she's burning magnesium here. Right, guys, what is in the air that will react with the magnesium? You see, magnesium is alone. When you burn magnesium, what is in the air that will react with this guy? What air is in the is in the air? What gas is in the air? Don't so fast lah. What is the gas in the air? The most reactive gas in the air is your oxygen. Okay, so your oxygen will come to your magnesium and gets married to your oxygen, married to your magnesium. So the white powder is your magnesium oxide. All right. Oxygen is the only thing that we will be using. You see, all the air that you inhale in, you're only using the oxygen because oxygen is the only gas we use. So B, does the white powder have the same chemical composition as the original material? Give your reason. Okay, is magnesium oxide same as magnesium? Is it the same? Is magnesium oxide and magnesium the same thing? Do they have the same chemical composition? No. One is with oxygen, one is without oxygen. Give your reason, right? Because chemical reaction took place. There was a chemical reaction, that's why they changed. Chemical reaction, yes, it has an extra oxygen because it reacted with extra oxygen. So they changed. They changed. The magnesium changed. It's not magnesium anymore. It's magnesium oxide. Right, so next C, complete the following word equation. They actually give you the answer here already. So this is your magnesium oxide. Okay, next. Iron filings and sulfur powder. Again, this is a typo. Iron react with sulfur. Same like just now lah. You see? Iron, sulfur, iron sulfide. So, state whether chemical change or physical change occurs when iron filing reacts with sulfur powder. This is a chemical change. Okay, this is a chemical change because the substance changed. Okay, the substance changed. The substances change their characteristics. Okay, so they are different from their original element. Okay, you see, iron is like silvery color, sulfur is yellow color. When you react these two together, iron sulfide should look grayish blue. They just look different from what they are alone. You see, when two things come together and they change, that is a chemical reaction. Because something changed, their structure changed. It's just like water, you see, hydrogen is a gas, H is a gas, O is also a gas, but H2O is a liquid. So you see, it's different. So they change, so this is a chemical reaction. So the equation, so iron plus sulfur, you get iron sulfide. Okay, this one you already know. Anyway, number 6. Okay, number 6. So this is sulfur powder and iron filing. This is actually last chapter's exercise. What is observed at the end of the activity? Guys, the mixture is stirred uniformly by using a glass rod. You see, just now, we know that iron and sulfur, they will react, right? But if I just stir it with a glass rod like this, will there be any change? Sulfide and sulfide have any changes? Or any difference? Sulfide is F. Sulfide is just S. Sulfate is SO4. Okay, so if it's copper sulfide, it's CuS. I couldn't bother with the charge. I think, yeah, it's CuS. And then copper sulfate is CuSO4. You'll be seeing this guy a lot. You'll be seeing this guy a lot, copper sulfate, in chemistry, in electrochemistry. You'll be seeing this a lot. You even see this in biology. You even see this in biology. Oh, no. When you add Fe to S, you just get FeS. It doesn't explain the SO4. The SO4 comes from sulfuric acid. Different. Different. Sulfate and sulfide is different. Okay, it's just like carbon and carbonate is very different. If you get what I mean. Right? So what is observed? Guys, do you see any change here? When I just stir it, I don't burn it. There's no fire, no heat here. Do you see them change? Do you see any glow? Do you see any fire? Do you see any smoke? Do you see anything? No changes. Good. No changes. You might say, sir, just now these two they will react, right? They will get married, right? And become iron sulfide, right? Yes, if you have fire. We call it activation energy. This is chemistry already, right? Sometimes you want to make compound, you need fire. You need heat so that they will start reaction. If you don't have heat, they are just going to stay there, right? Yes, fire is a catalyst. Yes, correct. So B, the mixture is heated using a Bunsen burner. Now name the substance form. Now you have iron sulfide. If it makes sense to you. All right. What is the type of substance form? This is a compound. You learned this last chapter, right? This is a compound. Give a reason. Okay, because they form chemical bond between iron and this sulfur. They have this bond in the middle. Remember what is a bond? What is a bond? That means they get married, like your compound. Mixture, they don't know each other. The friendship, remember? The friendship, the bond. If it's salt and sand, there's no friendship, no bond. So it's a mixture. Okay, guys, this was everything in last chapter. Kind of a repeat, actually. So number 3, predict what happens if a bar magnet is brought near the substance form. Give a reason for your prediction. Okay, guys, can magnet take the iron filings out? If I put a magnet here, will the iron filings stick to the magnet? Yes, right? But what about here? If this thing becomes FeS, iron sulfide, if I put magnet here, is there anything that will stick to it? No, right? You see they change because a chemical reaction will change you, right? So no substance is attracted to the magnet. Okay, give a reason. Why is it so? Because iron sulfide is not magnetic, right? Iron is magnetic, but iron sulfide is not magnetic, right? What I'm trying to say here is, guys, chemical reaction will change something. They will become a totally different thing. If you get what I mean. Okay? Are you guys following, Guys, are you guys following, I don't know why, my every Monday class, tends to be the deadest one. Like, everyone is like completely dead. Why? Monday blues, Monday blues, is it? Carl? Zhan? Tinting? Are you guys having Monday blues? I can feel it. You're not dead. Okay. Yeah, you're not dead. Zhan and Tinting, are you guys still there? Are you guys still there? Please don't die, Please don't die, Monday blues, I know. Monday blues. It's always like that one. My Monday classes are still there. Okay, good. My Monday class, everyone is like half day. No, I won't complain you. The more you talk, the happier I am. I mean relevant stuff lah. Okay, so I understand. Okay, I understand. So yeah, Monday is the shittiest day of the week. I understand. And the other end, the completely opposite, my Friday class is the most active one. My Friday class, I cannot even finish reading the chat because everyone is like so hyper. Very obvious one. You all really hate Monday, huh? Monday did nothing wrong, guys. Monday did nothing wrong. Why do you hate Monday? Okay, guys, let's go to Unit 10, shall we? Let's go to Unit 10. We have finished Unit 9, huh? Are you guys okay with Unit 9? Right, this is actually related to your Unit 8 one, the compound, the element, compound, and mixture is more or less the same thing. Okay, that's why they all go together. This is your Unit 1 last year. Huh? You mean Unit 10, or Unit 9? Okay, guys. Unit 10. What? You learn this as the first chapter of your... Why can't your school just follow the sequence, leh? You see, sometimes I really don't understand your schools, lah. Like, why can't they just follow normal sequence? You start with one. Yeah, I know, but why can't the textbook follow? You start with 1, and then 2, and then 3. Right? I don't know, lah. You see, the same as making cakes, lah. You see, when you... Okay, let's say you're following a recipe to make cake, right? You have two types of people. One that will follow the book to the teeth, right? And then on the other hand, you're like, there's other guy that goes, you know what? The book is just a reference. I'll do whatever I want. So apparently your school is that second one. But hey, as long as you learn, right? So anyway, Unit 10, Chemistry in Everyday Life, guys. This is a really easy, straightforward chapter because this is just, examples. Same as Unit 9. You see, Unit 9, we learn metals, famous metal and famous non-metals, right? Now we learn famous chemical change. Okay, famous reaction change, right? So there are two types of change around our daily life. We have physical change and chemical change. Okay, so very easy, guys. Very easy, guys. Physical change is like ice melting. It's like ice melting. When you take ice out from the fridge, guys. Yeah, oh, is it? Okay, guys. When you take ice out from the fridge, when the ice melts, does it change? Chemically, does it change? Do they change in terms of chemicals? No, right? Because you see, ice is H2O. When it melted to become water, water is still H2O. Right? Yes, this is a physical change. They are only changing their form from solid to liquid. They are still H2O. Chemically, there's nothing changed. It's still 2H and 1O. So, two or more substances mixed together physically, no chemical reaction. You see, melting, there's no chemical reaction, forms a mixture. Okay, if you're using sand and salt, okay, you get a mixture, does not produce new substance, there's nothing new coming out. Okay, the main thing is this. Okay, there's no new substance, right? Like I said, melting, dissolving salt in water. When you dissolve salt in water, you still have salt and water. There's nothing changed. All right. When you freeze a cup of water, it's just water changing from liquid to solid. Nothing changed. Right? But chemical change, something happened. Two or more substances mixed together chemically, that means they have a bond, like we learned 2 chapters ago. Chemical reactions took place, forms a compound. You see, now they become friends. Yes, that's good. This one can be separated by physical method. Okay, physical method like filtration, like magnet, like, okay, those we learned 2 chapters ago. All right, and this one produce a new substance. Produce new substance, like you see, rusting. Okay, rusting. Rusting is basically iron becoming iron oxide. Okay, they oxidize, so they become iron oxide. So that's a rusting. right? So why do we paint iron? Why do we protect iron? Why do we put a layer of oil on it so that oxygen doesn't react with them and make something rusty? Okay, then of course combustion is burning lah. Okay, combustion is burning. So when you burn something, you change something completely, right? So guys, what happens in a chemical reaction? Carl, did you learn this last year? So what happens in a chemical reaction? In a chemical reaction, atoms form new combination. All right. Okay, guys, basically chemical reaction is one pair of couple and another pair of couple. They are not happy with each other, so they rearrange. This girl, okay, let's say you have boy 1 together with girl 1. And then boy 2 together with girl 2. Right? So when reaction happens, when chemical reaction happens, they just change their partner. Now, boy 1 gets together with girl 2. Boy 2 gets together with girl 1. If it makes any sense. Okay, you are just rearranging, or both ways to learn. Okay, that means you are rearranging things. Right? So it's just like us, like, you see, it's just like us. You are with your girlfriend. Let's say you have a girlfriend. Next time you are not happy with her, you break up with her, you get together with another girl or boy, whatever, right? So this is chemical reaction. You changing your partner, okay? Because nothing is permanent, nothing is forever. So you will change things, okay? Even goes to your friend, guys. You change your friends time to time, right? Maybe last year you hang out with one gang, next year you hang out with a different gang, okay? Maybe not now, but sooner or later, next time, you hang out with different gangs. When you go university, you hang out with university gang. Right? So you see, you change your friend. So same thing here. You see, this magnesium and this hydrochloric acid. So the chloric decides to come together and couple up with magnesium, and you get magnesium chloride. Now the hydrogen is left alone. The hydrogen got dumped. So this is a chemical reaction. All right. So it should be noted that before and after a chemical reaction, no atoms are lost. Atoms are only rearranged. That's why you balance. Right? That's why you balance. Can you see one dark green here? You see, everything on the left side and everything on the right side should equal. You see, one dark green, two light green, two white. And then one dark green, two light green, two white. It's still the same. You cannot destroy atom. The atom doesn't just disappear. The atom, they are just rearranged. Oh, lead sulfate reaction. That means what? What's up with lead sulfate? Very interesting, man. I think why your teacher let you guys see all precipitation. Very boring one. You guys did this, right? Nitric acid. Okay, nitric acid plus lead. Sorry, sulfuric acid. My mistake. Okay, you will use sulfuric acid and you put lead, and then you get this white color precipitate. Is it like that? Or lead nitrate lah, lead nitrate. Okay, and then you will get this lead sulfate and they will precipitate as like a white thing at the bottom. Yes, white, yellow, white, each lah. Okay, each lah. This is salt. This is salt, right? You also learn this in the salt chapter, right? I don't know if your school is like more advanced in chemistry already, maybe they will teach you this too. Okay, anyhow, so therefore mass before and after a reaction should remain the same. That means if everything here is 10 gram, at the end you'll still get back 10 gram. They are just rearranged. When you have two boys and two girls here, at the end you still get two boys or two girls. No one disappeared. All right, no one disappeared. So example, when you add calcium carbonate to hydrochloric acid, there is a chemical reaction. So you see, calcium carbonate plus hydrochloric acid, you get calcium chloride, water, and carbon dioxide. So maybe here is 200 gram. At the end, what do you get? What do you get? You have 200 gram. You start with 200 gram. What do you end up with? What do you end up with? You still end up with 200. You cannot destroy mass. You get what I mean? You cannot just destroy atoms. Makes no sense. All right. So I have a question here, guys. I have a question. Yes, law of energy. At the beginning of the experiment, the weighing scale shows 250. Oh, it's 250. So we change this to 250. Okay, at the beginning it's 250. Okay, I weigh this thing. However, after 10 minutes, the weighing scale shows 207. Where is that remaining 43? Where is it? Why is it gone? Why is it gone? Yes, very good. That's your carbon dioxide. So you see, this 207 is this too. And since carbon dioxide is a gas, the gas disappeared. The gas ran to the atmosphere. So this guy should be 43 grams. So you see, when you add these two together, you still get back 250. Okay, yes. Not to say evaporated lah. They ran off. All right. So the answer here should be your carbon dioxide. Okay. It escaped into the atmosphere. Okay, they just go away already. Okay, they escape into the atmosphere. Okay, so knowing when a chemical reaction, sorry, there's a reaction takes place here. Knowing when a chemical reaction takes place. Okay, guys, I think you know what is chemical reaction already lah. But how can you tell whether something happened? How can you tell something happened? Okay, this is common sense. You know there's a chemical reaction whenever there's a color change. Okay, whenever there's a gas release. Okay, like just now, you should hear gas like fizzling sound. Heat is produced, this thing will get hotter or maybe even colder, right? Heat is produced or absorbed. Things will get hot or cold. pH change. Okay. Guys, you remember what is neutralization? You learned this in year 7. Year 7. Acid plus alkaline, you get neutral. So that's a pH change, right? And then, of course, formation of your precipitate, the lead sulfate you say just now, Carl. This is it. Right, so guys, common sense. You know it's a chemical reaction when all these happens. Okay, there's a color change, there's a something change, right? You can see or hear something, or you can feel something when you touch it. You know there's a chemical reaction. Okay, okay, easy, easy, so you know what? Yeah, I'm just gonna continue lah. See how far I can go today. Right, so reaction with, we have so many types of reaction here. We have reaction with oxygen, reaction with metals, other metals with oxygen. Okay, let's talk about oxygen. Let's talk about oxygen. Okay, if you realize something, right? All we talk about is oxygen. Right? All we talk about is oxygen. Okay, why? Because oxygen is one of the most common element in the world. Oh, you just learned it last 2 weeks, this thing ah. Why is it separated one? How your syllabus is weird. Why is it all over the place? Okay, reaction oxygen, reaction of oxygen. So you know that oxygen is everywhere, right? Like if you were to get, okay, you guys play Minecraft, right? If you get any minerals from the ground, if you get any minerals from the ground, big chance that it has oxygen inside, for sure. All right, so oxygen takes up 21% in our atmosphere. Many reactions around us involve the reaction with oxygen. Even you react with oxygen. When you eat, you take in oxygen to break down glucose. That is what we call respiration. Oh, hey, respiration. Okay, the reaction between a substance and oxygen is called oxidation. Guys, do you know what is oxidation? Do you know what is oxidation? I'm sure you can tell this is oxidation. Oh, I see. You are supposed to learn this next year in year 9. Oh, your school syllabus is weird. Right, so you know what is oxidation? You know how this happens? When you cut a piece of apple and when you don't eat it, you put there for like, I don't know, 20 minutes. This thing starts to turn brown. That is oxidation. Right? This happens to you. This happens to you. This is why we humans, we get old. Right? You get old, you start to have wrinkles, your skin starts to get bad as you old, as you get age, as you get old, you age. So oxidation, right? It happens. It's a nature. Apples oxidize, food oxidize, biscuits oxidize, you oxidize. It's part of nature. So respiration, this is oxygen. All living things carry out respiration to produce energy. This one you already know. We have talked about this plenty of times, right? So glucose plus oxygen, you get carbon dioxide, water, and energy. Oh, you know this, you know this, glucose and oxygen. This is what you use, glucose and oxygen, and then you get carbon dioxide, water, and energy. Okay, you learn this like plenty of times. Hang on, guys. Okay, next. Just a moment, guys. Sorry. Okay, sorry. Right. Next, you have your combustion. This is the same as respiration, actually. This is the same as respiration. So almost similar to respiration, combustion is used to produce energy. Okay, we use combustion to produce energy. Can you see this thing and this thing is almost the same? It's just that combustion, we don't use glucose. Combustion, we use fuel. Any fuel you want lah. Any fuel you want lah. You can use what you can use petrol. Okay, you can use petrol, you can use coal, you can use natural gas, wood. Where's the heat on the arrow? Oh, okay, good one. There's a heat here. There's a triangle here. Okay, nice. Right, so guys, what I'm trying to say here is what you do. Okay, guys, did you notice something? This is what you do, and this is what your car does. So actually, you and your car is not so different, right? You do this to get energy so that you can walk. Your car does this to get energy so that they can move too. You see the same? You see the same? You get the same product, you do the same thing. So basically, respiration and combustion, they are more or less the same, right? It's just that this one you don't get as hot. You photosynthesis. Okay, good. Teach me how. Imagine, guys, if you can do photosynthesis, how much money will you be saving? There's no need for lunch. Fine. Okay. So fuel is a substance that can combust to produce energy. For example, petrol, diesel, natural gas, wood, coal, paper. Everything has fuel. Everything is a fuel. Even your laptop is a fuel. You can burn your laptop to produce energy, but that is a shitty fuel. Okay? There's very little energy in your laptop. But say if you burn a piece of wood, it's a very good fuel because wood gives you a lot of heat. Right? That's why we burn petrol, that's why we burn diesel, because they are the best fuel. They give you the most heat. Right? Which is very bad for the environment. And of course, oxidation of food. I'm sure your mom asked you to eat your apple quickly after she cut it. Does your mom cut food for you? Does your mom cut food for you? I'm sure she does. Right? So guys, I have a question here. How do you stop this? How do you stop this? If you don't want your apple to turn brown, what should you do? What should you do? Yeah, dinosaur's body, basically. So what should you do? If you don't want to put in fridge, put fridge also turn brown or not? Put fridge also turn brown, leh. So what should you do? Anyone? Anyone? No lah, not so. You can put lemon on it, or you can put salt on it. Do you know this? Guys, when you squeeze lemon on your apple, it doesn't oxidize. It's still oxidized, but it's much slower. Right? So when we leave food in the air for a long period of time, some substance in the food might react with the oxygen in the air and become oxidized. This is how your food goes bad. This is how your food goes bad. Okay? So what you do is, Oxidized food changes appearance, smell, flavor, or even their nutrient. Oxidized food are usually spoiled and not suitable to be eaten. You know what is low feng? You know what is lao feng? You know when your cookie oxidized, right? It kind of turns soggy. It turns soft. That is when it oxidized, lah. Right? When you open a pack of biscuit that is expired, you will know. Okay, the biscuit just tastes soft and soggy. It's not crunchy anymore. Right? For example, oxidized fats and oil in food makes it rancid. Oxidized apple's flesh turns brown. You know it's rancid? Guys, have you eaten spoiled fats before? It's really smelly. Spoiled butter. It's really smelly. Spoiled potato chips. If your potato chips expired for 2 years, ask me how I know, right? If you die eat it like me, it's gonna taste freaking awful because the oil is really smelly, right? So to preserve food and stop it from being oxidized, in this case, oxygen is our enemy. You see, oxygen is our friend in respiration, but oxygen is our enemy during oxidation in your food, right? We can use something called antioxidant. What is an antioxidant? Antioxidant is something that can slow down oxidation and make food last longer. For example, vitamin A, vitamin C, vitamin E. You see, A's. Okay, beta carotene, lycopene. These things that will slow oxidation. Oxidation also causes body cells damage such as aging and cancer. You see, when you have oxidation, you will become older, you will start having wrinkles and you'll get cancer. Therefore, eating antioxidants also helps slow down oxidation in your body. So guys, vitamin A, C, E stops cancer. Reduce your risk of cancer. Something that you should know. Okay, so these are your antioxidants. You see, all the colorful fruits and veggies, they are your friend. They are antioxidants, right? Like, guys, you know what is pomegranate? Do you know what is a pomegranate? Did you know pomegranate is a very good antioxidant? Okay, we just don't evolve to be that way, Carl. We can't, right? So make sure you eat enough fruits. Grapefruit too, okay, but pomegranate is really good. Pomegranate is a very good antioxidant. So is avocado, so is broccoli. Guys, I don't know why people hate broccoli. Broccoli is good. You can make us do that. That will be another species already. You're an alien already. Okay, guys, you know what? I think I'm gonna stop here. I hope you learned something new today. Okay, at least you learn what is antioxidant lah, Carl. I don't think you have learned this in your lesson in your school. Go and Google what antioxidant is. This is how you fight cancer. Okay, so you do, huh? Oh, okay, then good luck. Okay, guys. I will end here lah, huh? I will see you next Monday, guys. Hope you have a wonderful holiday this Thursday. I will see you soon. Okay, yeah, sure. Okay, so see you soon. Take care, guys. Good night. Bye bye.